Okay, so first we will start with passive band pass filters. So we know low pass filter means it passes only low frequency signals. So this is the pass band and this is the stop band. And high pass filter means it passes only high frequency signals and it blocks low frequency signals. Okay, but in some applications, we want only selective frequency signals and isolate rest of the signals. So we can take the same example like what we had seen last week. So 1 to 100 kilohertz. So we can assume 1 to 25 is the low frequency. 76 to 100 is high frequency. In the middle range, whatever the frequency appears, this is called middle range frequency. So in some applications, we do not want low frequencies and we do not want high frequencies. We are only interested in this mid range of frequencies. So in that kind of situations, we can use these band pass filters. So band pass filters are useful in audio amplifier applications because in some audio amplifications, we are interested with only specific frequency range or circuits such as in loudspeaker, crossover filters, or pre-amplifier tone controls. Actually, it's useful in different applications. This is just few of them. So in such applications, it's really necessary to pass only certain range of frequency signals. Okay, so we can decide we want either wide band or narrow band. It's up to us. So we can design the band pass filter based on our application. So if you really want wide range, then you have to set up the R and C value. This is the resistor and capacitor value in the filter design accordingly. Okay, so we can also implement this band pass filter by using RLC components. So it can be RLC series components. We can implement this band pass filter, or we can just use this R and C only without L. So this L is a lossy component or magnetic component. Of course, it's better to avoid this in the circuit. It's because of the loss is heavy and also the cost is high in the inductors. So we can only use R and C passive components and we can design this band pass filter. Okay, so we already know how to design R and low pass and high pass filter by using R and C components. So in addition, we can also use some kind of amplifiers. It can be operational amplifier or transistors. So if you use this op amp together with R and C components, then that kind of filters are called active filters. So today we will start with passive band pass filter. It means we are going to design this band pass filter only using passive components, which are resistors and capacitors. Okay, so here also we have cutoff frequency. So in the low pass, we have also cutoff frequency here, FC, and the high pass, we also have the cutoff frequency, FC. So whatever the frequencies which is less than FC, then those frequencies can pass through the filter. Here, whatever the frequencies which are greater than this FC cutoff frequency, those frequencies will pass through the filter. So that is the concept of or the working principle of these low pass and high pass filters. So in band pass filters, as you can see here, there are two cutoff frequencies, F1 and F2, because it's in the middle range. So it needs to start somewhere and it needs to end somewhere in the middle of the frequencies. Okay, so the cutoff frequency in a simple RC passive filter can be accurately controlled using just a single resistor in series with a non-polarized capacitor. We will see how to design the circuit for band pass filter now. Okay, how can we connect, how can we design this band pass filter? It's very simple. By connecting or by cascading this low pass filter and high pass filter together, we can build or we can construct the band pass filter. It's very simple. I just put here high pass filter and then low pass filter. I'm just cascading together. Then it becomes a band pass filter. So how can we design the high pass filter, passive high pass filter? So we know the capacitor is in this mode and then the resistor in the parallel mode. So this is forming high pass filter. So this we had seen last week, because the capacitor is only passing high frequencies and blocking low frequencies. It's because of its reactance value. So XC, that is the reactance of the capacitor. But the low pass filter, we are just replacing the components or interchanging the position of the components. So resistor is going here, capacitor is coming here. So here then we can construct low pass filter. So for example, here the resistor is here and then the capacitor is in this parallel mode. So now the capacitor will pass low frequencies, block high frequencies. Okay, that is the property of this capacitor. It's depending upon the connection where you are connecting this capacitor. So now we are just putting together this high pass filter and low pass filter. So because you know the frequency response of this low pass filter and high pass filter, right? So here we have, so because of combining these two, so we get, you can see here, this is blocking low frequencies and this is blocking high frequencies. Since we are putting these two filters together, in the middle part, we are just allowing and we are blocking the low frequency range and we are blocking the high frequency range. So then we get this band pass filter. It's a very simple logic. So if you talk about the circuit construction by using components level, so here is the circuit. So we have the capacitor and the resistor. This is a high pass filter. And here we have the resistor R2 and C2. This is forming the low pass filter. We are applying the input between one terminal of the capacitor and the other terminal of the resistor R1. And we are getting the output here across the capacitor C2. Then we get this band pass frequency response. So unlike the low pass filter, which only pass signals of a low frequency range, or the high pass filter, which passes only high frequency range, that we know low pass filter, what the low pass filter is doing, what the high pass filter is doing. Okay, so a band pass filter passes signals within a certain band or spread of frequencies without distorting the input signal or introducing extra noise. So this is the high pass filter, or just HPF or HF. This is blocking the high frequencies and this part is blocking the low frequencies. So we get certain frequency range at the output of this filter. Okay, this band of frequencies can be any width. So we can control the width of this bandwidth. So it can be either very narrow or it can be very wide. So we can control, this band of frequencies can be any width and it's commonly known as the filter's bandwidth. Okay, so this is the filter bandwidth. So in any filter, we have the bandwidth. So here we have the bandwidth. This is the bandwidth for the low pass filter from 0 to FC. And here you can see the high pass filter also we have the bandwidth. This is called the pass band. This is called the stop band. So in each filter, we have the stop band and pass band, and we have the bandwidth. So this bandwidth here is from here to here, FC to maximum frequency level. And here we have F1 to F2, that is the bandwidth here. Okay, so this is the band pass filter. So now we will see the frequency response of the band pass filter. We already know this is the frequency response of the band pass filter, but this is the ideal filter. So in practical, almost we never get this kind of response, because practical filters, there is no brick wall, vertical response like this. There is always a slope. It will rise slowly and it will fall slowly. And we know the falling range roll-off rate is, this is called a roll-off, or we can also call this a fall off. So this is minus 20 dB per decade. Okay, so this is the band pass actual or practical band pass filter response.